In this unit, we are going to be going back and taking a look once again at horizontal and vertical particle motion, but this time now we know integration, so we'll be applying our techniques of integration to particle motion, to straight line particle motion. So a lot of this will be a review. The only new thing will be integration, but it's an important topic for us to take a look at again and apply our new knowledge. This topic is almost always on the AP exam as an FRQ. So let's begin with the position function. Typically S, X, or Y. S is in general. S of t is the general position function. If we're on a horizontal line, sometimes the position will be called X. If we're on a vertical line, sometimes the position will be called Y. So units would be in plane inches, centimeters, meters, feet, etc. Okay? Think of position as the location of the particle or object, okay, at any given time. Next up, the velocity function. We call that V of t. Velocity is the instantaneous rate of change. I'm going to get a highlighter here. There's my highlighter. Velocity is the instantaneous rate of change of position. That means that velocity is the derivative of position. Whatever your position function is, velocity is the derivative of that, which means velocity is the derivative of position with respect to time. I like to think of it this way because that way we can easily get units. So units would be units of position divided by units of time. So our units would be in things like feet per minute, meters per second, miles per hour, things like that. Velocity is related to speed, but they are not identical, always. Speed is the absolute value of velocity. So speed can only be positive. An easy way to think of this is like this. If you're driving in a car forward, your velocity is positive and your speed is positive. They are identical. But if you're driving in reverse, your velocity is said to be negative because you're going backwards, but your speed is still positive. You might say, I'm driving backwards at a speed of 3 miles an hour. The speed is positive. The velocity is negative. Okay, if velocity is positive, the object is moving to the right or up. If velocity is negative, the object is moving to the left or down. And if velocity is 0, the particle is not moving at all, and the particle is said to be at rest. Next up, acceleration. Acceleration is called A of t. And acceleration is the rate that the velocity is changing. So A of t, the acceleration, is the derivative of velocity. A of t is derivative of velocity, which means that A of t is dv dt. So we will need units of velocity divided by units of time. So velocity would be things like meters per second or feet per minute or things like that. Time would be in whatever your time is, so you are left with meters per second or meters per second squared. Okay, so that would be how you get units for acceleration. Acceleration is also the second derivative of position. If acceleration is positive, the velocity is increasing. If acceleration is positive, because acceleration is the derivative of velocity, if acceleration is positive, that means velocity is increasing. That does not mean that speed is increasing, because speed is not identical to velocity. To determine if speed is increasing or decreasing, we need to look at its derivative. Speed is the absolute value of velocity. So speed is increasing when its derivative is positive, when the derivative of the absolute value of velocity is positive. With a calculator, that is not hard at all to calculate. Without a calculator, though, it is cumbersome to take the derivative of a function in absolute values. So we remember the conclusion. Speed is increasing when acceleration and velocity have the same sign. Speed is decreasing when acceleration and velocity have different signs. That's the conclusion to what it would take to take the derivative of that absolute value of velocity. Next up, displacement. Also a review from, all of this is a review from last time so far. Okay, displacement is the change in position. Displacement is change in position. So position at our ending time minus position at our beginning time. Now that we know integration, change in position can also be written as an integral using fundamental theorem of calculus. Change in position is this integral. It's the integral of s prime. Because fundamental theorem says the integral of the derivative is the change in the amount, right? So this would be s of b minus s of a. And since s prime is v, displacement can be written as this integral. Okay? Total distance traveled. To find the total distance traveled by an object, we need to add up all of the changes in position when the object moves to the right, and all of the changes in position when the particle or object moves to the left. So if the particle changes direction at these 4 times in some interval from A to B, time A to B, then the total distance traveled from time A to time B is, okay, you would find the distance for the first segment and add the distance for the second segment, and then add the distance from the third segment, and you'd keep on adding until you got to your ending time. Notice the absolute values there because distance is always positive. Clearly, that is a cumbersome procedure, especially if you have 4 times where the particle changes direction. If it was just 1 time, it wouldn't be too bad. But with 4 times, that gets up to be a lot. Okay? So, because first you have to determine what time the particle changes direction. That would be finding when velocity changes signs. Velocity changes signs. And then you'd have to find the positions at each of those times, and then use that expression above to find the total distance traveled. If you have a calculator, though, it is far easier to use integration. And when we did your Riemann sum project, you used integrals to find your total distance traveled. You approximated the integrals with the Riemann sum, but the integral gave you your total distance traveled, and you integrated speed. You integrated speed to find your total distance traveled. So the total distance traveled is the integral of speed. So total distance traveled is the integral of speed, written as the absolute value of the velocity. I summarized everything in this little table on your notes packet. So this would be something to kind of keep handy as you are studying and reviewing. Okay? All right, let's do some examples. That took me about 10 minutes to go through. Let's look at some examples now. Okay. A particle moves. This one has a calculator, so I'm going to grab my calculator. This This one we have a particle moving along a line so that at time t, where t is between 0 and pi, its position is given by this equation. So they give us the position. What is the velocity? What is the velocity when the acceleration is 0? So we need to find when is the acceleration 0. Okay, I can think of a couple different ways to do this, and I just now took a better look at my equation for s, for position, and I asked myself, how easy is this to take two derivatives of? And my answer to that is, it really is not that hard. I could let my calculator do it, but I think I'm going to just take this by hand because it's so easy to take by hand. The velocity is the derivative of position. The derivative of cosine is negative sine, so this would make it a positive 4 sine of t. This is negative 1/2 t squared right here. So when we take the derivative of that, it'll be a negative 1 t, and then the derivative of 10 is 0. Acceleration is the derivative of velocity. The derivative of sine is cosine. The derivative of t is 1. So acceleration is that equation. So I'm going to go to my calculator. I'm sure it's a mess. Let me clear out what's there. I'm going to put acceleration in for y1 because I want to see when is that thing in between 0 and pi. So that's all we care about. In between 0 and pi, when is that, forgot my close parentheses, when is that 0? So I'm going to put that in for y1 and 0 in for y2. In my window, I'm going from 0 to pi. It's already set on negative 4 to 4 for my y min and y max. I think I'm just going to leave it there. And go ahead and look at a graph. So that's 0 to pi, and I see acceleration is 0 one time. I need to find out what that t value is. So second calc 5 for intersection. Enter, enter, enter. And this is equal to 0 at time 1.318 dot dot dot. I'm going to store that in for a. So I'm going to go to my home screen, store that x value in for a. To get the store button, remember that's above the on button. So now my calculator thinks that that is a. And now we were asked to find the velocity there, so I'm going to go to my velocity equation and I'm going to put in a for t. So I'm going to type in 4 sine of a minus a and I get that. So that is right there. So my answer is D. And we move on. Now we have quite a long FRQ, free response question. And they tell me the velocity of a particle moving along the x-axis is given by v of t here. And they give me a window. I always like it when they give me a window. And then they tell me a position. The position at time 0 is x of 0 is 2. Okay, I'm going to begin by putting this in for y1. Okay, so I'm going to go to my calculator. I suggest you do that as well. If they give me a complicated equation, I'm going to put that in for, not that it's that complicated, but I'm going to put that in for y1. So x minus 7, where x is my time, cosine of x. And then for my window, I'm going to go ahead and set that up, 0 to 7. I don't know what my y min and y max need to be, so I'm just going to leave it negative 4 to 4. And let's go look at the problem. Part A. what is the acceleration at time 3? Well, the acceleration at time 3 is the derivative of velocity at time 3. I need to say that. You must say that to get credit. So all I need to do is find the derivative of the velocity at time 3, and the velocity is what I have stored in for y1. So go to my home screen. The derivative of y1, to get to y1 I do alpha, and then I need to get up here to f4. So alpha f4, y1 at time 4, because at time, did I say 4 there? 3. At time 3, since that's what they wanted, and I give my answer correct to at least 3 decimal places. So negative 0.425 will do it. If you want to, since the following digit is another 5, we can round this first 5 to a 6 if you want, but the first 3 you see are fine. If in doubt, give a couple more, give 1 or 2 more if you want to. Okay? You have to give at least 3 decimal places to be correct. So again, we need to see this. We need to see, of course, the answer. Part B, what is the position at time 7? Well, we were given the position at time 0, and now we want the position at time 7. And we know velocity. And velocity I know is the derivative of position. So this is screaming for me to use the fundamental theorem of calculus. X at the time I want, time 7, minus x at time 0 that I was given, is the integral from 0 to 7 of x prime, which is v. Okay? The difference, the change in x is the integral of its derivative. Okay? So x of 7 will be, I'm going to take this x of 0 to the other side, and while I'm at it, I'm going to put in the value that it is. It's 2. And then I'm going to let my calculator do the rest. So that's my equation. Pull in the calculator. Okay, 2 plus the integral, math 9, 0 to 7 of y1 with respect to x. 1.753, give at least 3. And you know what? Okay, yeah, that's right. Okay? I didn't get the same answer before. Oh, I see what I did wrong. Oh, no, that's right. That's good. We're good. Okay. Part C. On what intervals between 0 and 7 is the particle moving to the left? Well, the particle is moving to the left when the velocity is negative. So if I graph velocity, and I have the equation for velocity, if I graph velocity, all I have to do is see where it's negative, where it's below the x-axis. From 0 to 7, so I'm pretty sure I already put 0 to 7 in there, I did. So I'm going to graph velocity from 0 to 7. And I cannot see down here all that well, so I'm going to go and see a little bit further down on my y-axis, maybe to negative 10. There we go, that's plenty. So this is velocity, and it is negative from 0 to this value, and then again from this value, looks like to 7. So I'm going to find those two values, second calc, intersect, enter, enter, and then I'm going to guess 1 to get over to this one. So from 1.57079, blah, 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 that's an important number, so I'm going to go save that in for A. So second quit, S store A. Now that's stored in there. So I'm going to say what I'm doing. V of t is less than 0 on the interval 0 to 1.5707, and from, let's go get the other values. So second calc, intersect 5, enter, enter, and this time I'm going to guess 1, 2, 3, 4, 5 to get this one, 4.712, and I'm going to go store that in for B. So, and from 4.712 to 7. Okay? Now, right at, and I'm doing this because they gave me these closed boundaries, so I need to consider what's happening right at 7 and right at 0. Right at 7, this velocity is 0, and I know it is because of the equation for velocity. If I put 7 in for t, this whole thing is going to be 0. So I do not want to include 7, because the particle is not moving left right exactly at 7. When t is 0, the velocity is negative. So I do want to include the 0 there. So the particle is moving left on those intervals. Okay? Worded it a little bit differently. I don't like the way I worded that. I should have said the particle is moving left on these two intervals since v of t is negative on those intervals, or there. Okay? That would been a little bit more elegant way to state that answer. Okay. Alrighty. What is the displacement of the particle on this interval? So displacement with a calculator is the easy one to find. I'm just going to use my integral. So displacement is the integral from 0 to 7 of just v. Easy peasy. That's the difference of the position values, right? So from 0 to 7, okay, alpha F1 or F4, like that. And the displacement is negative 0.2460. Easy peasy with a calculator. What is the total distance traveled? Another easy thing to find with a calculator, if you know the formula for it. Total distance traveled is the integral of the absolute value of v, because this is speed. The absolute value of velocity gives you displacement. The absolute value of speed gives you total distance traveled. Okay, so Math 9, 0 to 7, absolute value. The quickest way to get to the absolute value, I think, is under F2. So alpha F2, it's the very first thing. Now we go and get our Y1. And the total distance traveled of this particle is 15.6798, at least 3 decimal places after the decimal point. All right, is the particle speeding up or slowing down at time 5? Well, we need to find v at time 5 and a at time 5. And we really don't care about the value there, we just need to know their signs. So v at time 5. V is our y1, so v at time 5 would be y1 at time 5. And that is negative 0.567. Again, I don't care about the value, I only care that it is negative. So I'm just going to say is less than 0 because it's negative. And now for acceleration at time 5, I need the derivative of velocity. It is also negative. So a at time 5, I should say what I'm doing here. So I took the derivative of velocity. It is also negative. So now I can say the particle is speeding up at time 5 since v of 5 and a of 5 have the same sign. They're both negative. Okay? G. In the interval 0 to 4, at what time is the particle farthest to the left? I'm interested in why they changed. It was 0 to 7, and now they changed it to 0 to 4. At what time is the particle farthest to the left? Let's take a look at our velocity graph from 0 to 4. Well, there's our velocity graph from 0 to 4, right? For this piece, for this stretch, velocity is negative. That means the particle is doing what? When velocity is negative, the particle is moving to the left. So the particle is moving to the left until this time. After that time, the particle moves to the right because velocity is positive. So the particle moves left until it gets to this time and then right afterwards. So the particle has to be farthest to the left at that time. So I'm going to say that. This time, by the way, we've already found that time. That was our 1.570 that we found up in part C. So I'm going to say the particle moves to the left until t equals 1.570. Since v is less than 0 there, and then the particle moves to the right after t equals that same time, since v is greater than 0 there. I might want to clarify on 0 to 4. Okay? Therefore, the particle is farthest left at t equals 1.570. Okay. Last up, what is the average acceleration? The average acceleration from time 0 to 7. Average acceleration will still have acceleration units. We still want acceleration units. How are we going to get acceleration units? And I say that because when students see average acceleration, a lot of times they want to do a of 7 minus a of 0 over 7 minus 0. They want to do that, but if they do that, you're taking units of acceleration and dividing by units of time. that is not going to give you units of acceleration. To get average acceleration, so to do average acceleration, we need the change in velocity divided by change in time. That's going to get us units of acceleration. That's what we want. Okay, so I'm going to do that. Velocity is in our calculator. So I'm going to need up on top y1 at 7 minus y1 at 0 divided by 7 minus 0. And our average acceleration is 1. Alrighty, so that was a rather long problem. A little bit of lots of things in there. Not an FRQ on the AP exam would not have all those parts to it. Okay, let's do some multiple choice questions. The position of a particle moving along the x-axis is given by the twice differentiable function x. If x of 2 is negative, x prime of 2 is negative, and x double prime of 2 is negative, which of the following statements must be true? Okay. Well, x of 2 is negative, means that our position, if this is 0, our position at time 2 is to the left of the origin. X prime is negative. That means the velocity is negative. So the particle, if the velocity is negative, the particle is moving to the left. So I know the particle is moving away from the origin. So not towards the origin. It has to be moving away from the origin. And next up, I want increasing or decreasing speed. So for speed to be increasing or decreasing, I look for the signs of velocity and acceleration. Well, velocity is negative, and the second derivative of x is acceleration, so v and a are both negative. Negative. So they have the same sign. So same sign means the speed is increasing. So we have increasing speed. So the answer here is D. Next up, we have a particle moving along the x-axis so that its acceleration at any time is this expression. Okay, they're giving us acceleration this time. And this one is a no calculator one, by the way. If the initial velocity of the particle is 6, so v at 0 is 6, at what time in between 0 and 4 is the particle farthest to the right? Okay, I'm thinking we need to get an equation for velocity. Yeah? How do we get velocity if they give us acceleration? Well, we integrate acceleration to get velocity. So to get velocity, we integrate acceleration, because the derivative of velocity is acceleration. So that's what we're going to need to do. So acceleration is 2t minus 7. Okay, so the antiderivative here, antiderivative of 2t is t squared, antiderivative of negative 7 is negative 7t, and then we have plus c. We need a constant of integration there. Okay, and we're going to use our initial velocity to find c. So v at time 0 would be 0 minus 0 plus c, but they tell me that it is 6. So c must be 6, and velocity must be that equation. So now I know velocity, And I want to find when the particle is farthest to the right, so I need to see when is it moving to the right, when is it moving to the left. So I'm going to sign chart velocity. To sign chart it, we need to find when it is 0, so I'm setting this equal to 0. I'm going to go ahead and factor this, and I don't know why I put 6 there. That should be a 7. I'm going to factor this, and that factors into t minus 6, t minus 1. I'm setting that equal to 0 because I'm going to sign chart velocity. I get t is 1 and 6, but in my interval they told me to stop at 4. Since they told me to stop at 4, I'm not going to consider the 6. It's out of my range, out of my actually domain. Okay, so on my sign chart I'm starting at 0 because they told me to. I'm including 1, and then I'm going to end at 4 because they told me to. Okay, and I am sign charting velocity. So if I put in a number here like 1/2, if I put 1/2 in for t, I'm going to get a negative from this section and a negative from this section, and that's a positive. I know I'm going to change signs around 1 because 1 came from an odd powered factor. So I know I'm going to change signs around here. If that process bothers you, just put in a number here like 3, and you'll still get a negative times a positive. That will be a negative. Okay, so here we're moving to the right, the particle is moving to the right, and here we're moving to the left. So what time is the particle farthest to the right? It has to be farthest to the right at time 1. B. Okay, next up, number 5. A particle moves along the y-axis this time so that its velocity is given by this messy equation. This is with a calculator. I can always tell when they give me a messy equation it's going to be a calculator active question. At time 2, the position of the particle is y equals 2. What is the position at time 4? If we need position and they give me velocity, I need to integrate velocity to get position, right? Because velocity is the derivative of position. So fundamental theorem here, because they gave me a position and we're looking for a position. So the position at time 4 minus the position at time 2 will be the integral from 2 to 4 of y prime, which is velocity. So y at time 4 is what I'm looking for. I'm going to move y at time 2, which is negative 2, over, and this is what I'm going to put into my calculator. Okay, negative 2 plus the integral from 2 to 4 of that velocity function, which is, it's a little blurry there, which is 7 minus 1.01 to the negative t squared, 10.176 C. Okay, number 6. A particle moves along the x-axis, so at time greater than 0. Its position is given by this equation. What is the velocity? What is the velocity? At the first instance, the particle is at the origin. Well, the particle is at the origin when the position is 0. So we need for the position to be 0. I'm going to go do that on my calculator. In for y1, I'm going to put the position, and all I know is that the time is greater than 0. So I'm just going to leave it at 0 to 4, which is what I had it at. We want the first time, so it'll just be the first time that this graph crosses the x-axis. I'm going to go back to -4. Okay, there's only the one time that it crosses the x-axis, and that is the first time here. So second calc 5, enter, enter, enter. At t is equal to 2.467 ... I'm going to put that in for a. X store a. And now I need the velocity there. So I'm taking the velocity at that time, which will be the derivative of x at that time. So math 8 of my y1 at time a that I just found. Negative 0.318. C again. Okay. Number 7. Particle moves along the x-axis from 0 to 5 at this velocity. At time 3, the position is 5. Find the position at time 2, and no calculator. No calculator this time. Okay, we can do this. All right, so fundamental theorem again, because if we want position, we have to integrate velocity, because velocity is the derivative of position. So the position at time 2, actually they gave me time 3, didn't they? So I'm going to write that one first. The position at time 3 minus the position at time 2 is the integral from 2 to 3 of the velocity, and they gave me velocity here. Okay, so we need to do this by hand. They gave me x of 3 is 5. Okay, to integrate this, I'm going to distribute everything. So this is 3 times t squared minus 4t plus 3. You know what I'm going to do? I'm going to take that 3 out. I'm going to take that 3 out. Well, yeah, I'm going to take that 3 out. Should I take it out? Yeah, I'll take it out. I was questioning it because I see what that first term is going to be, but that's fine. All right, we have 3 times. Okay. The integral, the antiderivative of t squared is 1/3 t cubed. That's why I kind of wanted to keep that 3 there. But I can take care of that in a second. Minus, raise your power by 1, divide by your new power. And the antiderivative of 3 is 3t. And we're going from 2 to 3. So 5 minus x of 2 is equal to, I think I am going to distribute that in there, you guys. I think I will. So this is going to be t cubed minus 6t squared plus 9t from 2 to 3. Should just left that 3 in there. Oh well. Moving on, we're going to put 3 in for t. So that'll be 27 minus 6 times 9 is 54 plus 27. Ooh, 27 plus 27 is 54, so this whole thing zeroes out. Minus 2 in for t, so 8 minus 6 times 4 is 24 plus 18. So we have 5 minus x of 2 is negative, okay. 8 plus 18 is 26, minus 24 is 2. So this is negative 2. So negative x of 2 is negative 7, and x of 2 is 7. 7. So this has been motion using integration. Sometimes. It's been a review of motion, and it's been using integration with it as well. In your notes, you guys, I did put a blurb on this next page, is a blurb on the AP exam. And I wrote this up because motion is almost always the topic of one of the FRQs on the AP exam. So we want to make sure we really get motion down well. Sometimes it's in the calculator section, sometimes it's in the no calculator section. Okay? And that made me want to give you guys some information about the AP exam. I thought you might be interested in it. So I'm not going to read all this to you, but it's there for you if you want to take a look at it. Okay? Nothing, we will definitely be looking at this again when after spring break when we start reviewing for the AP exam. But it's good to get your eyes on it. All right? And that is motion with integration.